Hi, I'm Joe from Ready Made RC. Welcome to our multi-part series on how to build a mini multi-rotor. We're going to start off today with a Hellbender 204 V2. And I'm going to show you how to build it into this aircraft right here. This aircraft consists of the 2204 Blue Series 2300 kV motors, 30 amp race ESCs, the Dodo flight controller along with the Dodo PDB. We have our Cricket V2 200 milliwatt, 700 TVL Fat Shark V2 with a GoPro lens. We also have the team mount for the camera here. All the items that will be in this build will be in the description below. Alright, first we're going to start off with soldering. One of the best tips that I can give you is to have a good iron. Here at RMRC we prefer to use the Tenma soldering iron. This thing is digital, heats up within about a minute, and is one of the best irons I've ever used. I generally like to keep my iron at 750 degrees so I can get my wire hot quick without heating up the rest of whatever I'm soldering. What I'm going to start off with is trimming these wires down on the motor. They're way too big for the application that we're using. So I'm going to trim them down to about an inch long. Okay, now we're going to strip these wires. We'll use a just regular wire stripper. And then we'll make sure that the wires are straight on there. I'm going to grab my handy dandy RMRC soldering jig here to place my motor in it upside down to hold it while I tin these wires. If you look at the end of this tip, it looks a little hazy. What we're going to do is clean it in the tip cleaner. So we just dip it down in there. We're going to put just a little bit of solder on there so it's nice and shiny. Now we're going to touch that solder onto the wires and add just a little bit to coat the wires. And then clean afterwards. Alright, next we're going to open up the ESCs and tin the end of those. And don't forget there is a small piece of heat shrink inside these ESCs. You want to make sure that you set that aside, that you don't throw it away. A little tip if you're going to be using these alligator clips is you can put thick heat shrink on them to help protect the circuit board, but you should absolutely try not to get them on the actual circuit board itself. If you look when I'm doing this, I'm crimping it on the wires so the wires will hold the circuit board. Tinning an ESC is about the same procedure. All you're going to do is tin right here on these 3 solder tabs. Now on this particular one, there's not a whole lot of room, so you have to make sure you do it quick and with a very hot iron. If you don't, you'll heat these chips up, the FETs, and they will fall off and not work. Alright, next we are going to take the ESC and motor and solder those together. You don't have to worry about motor direction on these because you can access the settings in BL Heli on these ESCs and reverse motor direction that way. We'll go over that later. Alright, now we have all 4 of our motors and ESCs soldered up. Alright, next we have to put the heat shrink on the ESCs. The best way to do this after you have your motors on there is to slip them over the servo wire and the power wires going to the ESC. So we're just going to slip those right on over. Make sure the whole ESC is covered and it's kind of centered in the heat shrink. I'm going to go ahead and do that to all 4 of them so I can heat shrink them at the same time. Alright, next we're going to use a hot air gun to heat up the heat shrink. If you get it too close or leave it on there too long, the heat shrink will actually break apart and then come off there and then you'll have to redo it. You want to get it to where it's just tight around the electronics. As you can see on this one right here, it's nice and tight around the electronics and all the connections are covered. Now all our ESCs are covered with the heat shrink and should be protected from shorting out on the carbon fiber frame. Alright, next we're going to do the PDB. I'm going to go ahead and get these motors out of the way. The PDB and flight controller we're going to be working with today is the Dodo Rev 3A and the Dodo PDB. I'm going to show you guys how to solder up the connectors for Spectrum, PPM, and S-Bus on the Dodo, as well as how to install the PDB for the Dodo. And before you mount this to the PDB, if you want to put pins for any other connectors or LEDs or buzzers that you want to use on this, put them on before you install the PDB. Alright, right here we have a small Spectrum plug. I'm going to show you how to install this. There's two different ways that you can install this, but for this particular build I'm going to install it the factory way. The correct way to install this is you slide this into the pins with the plug facing out on the side with the chips. Now, if you wanted to mount this upside down so that you have a flat surface to mount your receiver on or something like that, you would take this plug and put it on the back side, but this is where it gets tricky. The plug has to be facing the inside of the board because it's opposite if it's facing the outside on the other side. If you want to hook up PPM onto the Dodo, the top 3 pins on the right side of the board here will do that. Your top one is ground, your middle one is power, and your last one is PPM. For S-Bus, you're going to use the power and the ground from the top, but then your signal wire is going to go on number 3. Number 3 is UART3RX because it is receiving the signal from the receiver. Okay, I'm going to show you guys how to solder up the Spectrum plug. We're just going to tin our tip. And that's all there is to soldering up the Spectrum plug. Alright, now I'm going to install the PDB onto the Dodo. A quick side note, if you're going to put pins on this, you don't want to put them in there very deep so they stick out the back. Or if they do stick out the back very far, you can nip them off with a pair of side cutters. You just don't want them going through the foam on this and rubbing into the power distribution board because then it will cause issues. This is a simple board. You're just going to take this and place it over top of this with the pins through the holes. You'll see the pins poke through a little bit. Alright, so as you can see, the pins just barely visible. Now we're going to go ahead and solder those pins on. Just want to hold it on there just for a second so that the solder goes down into the pin. You get a nice clean solder joint. And if you get any solder joints that are kind of bubbled up, you can go back over them just by touching them with a hot iron and let it flow in there, and it should clean it right up. What I'm going to go ahead and do, because I already have this power distribution board out, is I'm going to tin all the solder pads around the outside. Your middle pad is going to be your signal pad. Alright, now we have our PDB all soldered up and tinned, ready to go. Okay, next we're going to continue with installing the flight controller on the main plate here. The bottom of the plate will have these countersunk screw heads. So that's going to be your bottom. You're going to take these countersunk screws, the 4 for the flight controller. They're the ones that are a little bit longer. Put those in there. And hold it with your hand so it doesn't push through. Now a tip with these flight controllers is to have your USB facing out the side so it's easier to access for programming. So you see the screw comes up all the way through. If you wanted to, you could use smaller screws for this, or shorter ones. Now that that's on there and secure, I'm going to take my nylon nuts and secure the flight controller down. And get them started on there by hand so that I don't cross thread them. I'm going to have to take another Allen wrench to hold the bottom so it doesn't spin. Alright, now we're going to take our motors. We need to go through these and check to see which ones are counterclockwise and which ones are clockwise. So now we have them separated with clockwise and counterclockwise. And now we're going to install these on the frame. We're going to screw them in from the bottom, get them nice and secure, and then we will trim the wires enough to where that they fit to the power distribution board, and we can install those by soldering them on. You want to make sure that the motors that you put on, all these quads, when they spin up, the motors spin towards the inside of the frame. You want to make sure that you hold the nut with a driver or your finger and then spin the motor in the direction that the prop is going to be spinning in the final assembly. And if it's tightening up, that's where you want that motor. If it's loosening up, what will happen is mid-flight, your props are going to be loosening themselves on the nut and your prop will come off and you will crash. Okay, now that our motors are installed, we are going to begin to lay out our ESCs. So we're going to lay our ESCs flat and make sure that these holes for the standoffs aren't blocked by the wires. And then we're going to trim these off to where they touch the power distribution board. They'll actually overlap it a little bit, and then we will strip them, tin them, and solder them on. Alright, I'm going to cut these just a hair bit longer than it actually needs to be. But that's so that I can make sure I have enough room. Alright, I'm going to strip the wires for the ESCs so then I can tin them. Alright, next what I'm going to do, I have all the wires stripped. I'm going to tin all the wires at once. We'll go ahead and get that done, and then we will solder them to the power distribution board. These thicker wires will take a little bit more heat to get the solder all the way through them. You want to make sure that you cover the entire wire with solder, that it goes all the way through, because if you just get one side, you're not going to get a good connection on the wire. Alright, now all our wires are tinned. We're going to attach them to the PDB. Sometimes when I'm doing small stuff like this, I like to use a pair of tweezers to hold the wire while I attach it to the board. So we're going to start with the bigger wires, actual power wires first, and we're going to attach those. And then we're just going to wait until it heats up and goes all the way through, and then let off. And then hold it there for a second while it cools. And that joint is nice and tight. Now the signal is going to go in the center of these two. There's a small pad on the PDB. On that pad, the center one is going to be the signal. There is no negative one. The negative one we're going to piggyback on top of the negative going to the ESC. Some ESCs have issues with needing a better ground. If that is the case, you'll want to take your ground wire and run it out here to the actual flight controller and put it on one of the grounds on the bottom right here. All of these are grounds. Alright, the next step that I'm going to do is I'm going to solder on the XT60 onto the PDB. This is just a pigtail I had laying around, so I'm going to reuse it. On the side of the XT60, it will say which side is negative and which side is positive. So we're going to go ahead and solder that up. One of the cool features that is on this frame is the little holes right here. You can put a zip tie through there to help reduce some of the stress on the wires during a crash. Okay, next we're going to install the wires for the video transmitter. This is the wire that goes to a 3-pin camera cable, and it has a JST on the end. For this particular build, we're going to cut that off and solder it directly to the PDB for a nice clean build. Okay, I'm going to solder these just directly up to the PDB in the front. Get it good. There we go. Okay, next we're going to install the team camera mount for the Hellbender. On the bottom, you're going to have recessed spots for the screws for the bottom of the camera bracket. Okay, as you can see right here, with the mount facing out like this will work for the Runcam Swift and the HS1177. For our application, we're going to be using the Fat Shark camera, so we're going to turn this around so that the camera bracket is more recessed in there. It'll add a little bit more protection for the camera. Okay, now we're going to install the camera on the Hellbender. With the Fat Shark camera, you want to make sure that where it says CMOS 700 V2, that's facing up. That is the top of the camera. So we're just going to remove the old lens and screw the new one in, and we will worry about focusing it once we get all our video equipment put together. For now, we're just going to lightly adjust this screw so it puts a little bit of pressure on the camera to hold it in place. Alright, now we are going to add the standoffs onto the frame. Again, the countersunk screws go on the bottom where the button head screws go up top. Okay, now we're going to install the Cricut onto the top plate. The top plate has two mounting options for the Cricut. You can run it further up front and have the antenna stick out the back and secure it with a zip tie, which is how we're going to do on this build. Or you can place it a little bit further back and use a 90-degree SMA to get the antenna stick directly out the top and offer a little bit more protection for the SMA. Alright, there we go. The nuts are on there, nice and tight and secure. I'm going to go ahead and put this on here. Get it nice and tight. And then right here there are two holes. We're going to use those with a zip tie to secure this down. Okay, now we're going to take a zip tie and place it through here to help secure the antenna down. And we'll just snip off what's left there. And then that is a nice secure spot for the antenna. It gives it a nice low profile for when you're racing and trying to make it through gates. Alright, the next step is going to be plugging in the video transmitter into the wiring harness that we previously soldered up. So it's just a quick little plug. And then the 3-wire plug here we are going to plug into the back of the camera. Okay, I'm going to show you guys how to use some of the holes that are in the front up here to help secure some of these wires down so they're not just flailing all over the place during a flight. So we're just going to place the zip tie through the hole, put some of the wires in the bundle. Alright, so we have the zip tie through the hole. We're just going to take some of these wires, kind of bundle them up there and attach the zip tie. Now we're just going to plug in the video transmitter. Now we're going to secure the top plate onto the frame. Alright, so that's the built Hellbender. Just a quick side note, if you're going to be running the Cricut up front, you will have to put this set screw towards the bottom of the frame so it doesn't hit the Cricut. So we're going to flip that over, tighten it up, and reinstall it. One of the cool features about the Hellbender team kit with the team mount here is an easy adjustability of the camera angle. You could start off at somewhere around 20 degrees all the way up to somewhere around 60 to 70 degrees if you really want to get that fast angle. One of the really cool things about the Hellbender is the main plate comes with a lifetime warranty. So if you smack this thing into something so hard that you break an arm or something like that, all you have to do is contact the guys in the support ticket system at readymaderc.com and they will get you sorted out with a new main plate. Alright, we are going to be using a 200mm RMRC strap for this. There's a couple different ways to do this. If you do a traditional build where you have the PDB a little bit higher up, you could just strap it through there like normal. But for this particular build, because we went with a low profile on the flight controller stack, we're going to have to do things a little bit different. You're going to place a strap through the hole on the side of the frame, like so. and pull it completely through. You'll see that the top of the buckle is still there. You'll see that the buckle stays up top here. If you want, you can trim half the buckle down to make it a little bit cleaner. And then you will put this through the other side of the frame. Don't forget your magic gel pad here that goes inside of the frame here. This will help protect your battery a little bit during impacts. Then you're going to take your battery, slide it in, and then when you need to tighten it up, just like that. So there's many different ways of mounting the ESCs on the arms. You can do heat shrink around the arm, but then you would have to do that before you mounted the motor on here. You could do double-sided tape underneath, or you can wrap electrical tape around the arm. Most people prefer the electrical tape option because it's easy to change them out if you need to, and well, electrical tape is very cheap. This concludes the Hellbender 204 V2 build. In our upcoming videos, we will be going over the basics of flight controller tuning and setting up receivers such as S-Bus, PPM, and Spectrum satellites, and all the needed information to get you in the air with your Hellbender.